So we're going to be looking at solving quadratic equations in this video using methods highest common factor and difference of two squares. In the next video we'll look at solving quadratic trinomials, those equations that have three different terms. But in this one, first of all, we're going to start off with probably the easiest of the methods, which is highest common factor. So this example is a highest common factor. Now the reason I know that it's the highest common factor is because there's common factors in the two terms, and that's where we'll start. So if I look at 2x squared plus 8x, then there's a highest common factor there of 2x. So 2x divided into 2x squared leaves you with x, and 2x divided into 8x leaves you with positive 4. And that's all equal to 0. Now, you've done the factorization now, so they're two factors, the 2x and the x plus 4, two different factors. And when you multiply those two factors, you're getting an answer of 0. But the only way that you can get 0 by multiplying two different terms or two expressions is that one or both of them are 0. So that means that we let 2x equal to 0, or we let x plus 4 equal to 0. Okay, and from there we're just going to solve. Like they're fairly straightforward linear equations. So in order, that's 2 times x is equal to 0. So I'm going to divide both sides by 2, remembering that that's a equation because it has an equal sign in it. And that means that what I do to one side, I have to do to the other side to keep it balanced. So x is going to be equal to 0, or over on this other side, I'm going to subtract 4 from both sides, so that I'm just left with x is equal to negative 4. So there is the answer for the first one using highest common factor, 0 and minus 4. So if I move on now to a different example. So this time the example I'm going to look at is x squared minus 9 is equal to 0. Now, compared to the first example, here there's nothing common, but here's an example of where I can use difference of two squares. Now, the word difference in maths means minus or negative. So you can only use this method where it's a negative, it's a square minus another square. So you might be thinking, well, 9 isn't a square, but we can express it as a square, and that's where it's a difference of two squares. So I can really express that, well, x is already in a square, that's x squared, negative, and 9 is the same thing as 3 squared. Now you've got the bulk of the work done already for this one, and all we have to do then when we have a difference of two squares, we can start off with two brackets, put x at the front of both of them, put 3 at the back of both of them, and then you just put a plus and a minus, and that's equal to 0. So again, like the last equation and like most quadratic equations that you'll get, you have two different terms being multiplied by each other to get 0. So that means that one of them or both of them must be equal to 0. So x plus 3 is equal to 0, x minus 3 is equal to 0. And again, I want to get x is equal to, I want to solve these. So I'm going to minus 3 from both sides here. The 3's cancel. And I'm left with x is equal to negative 3. On the far side, I'm going to add 3 to both sides. And then I'm left with x, and again, sorry, the 3's cancel, and I'm left with x is equal to positive 3. So x is equal to negative 3, positive 3. And there is your second quadratic equation solved. Now I'm going to look at another example of difference of two squares. So the third example, I'm going to look at 16y squared minus 1 is equal to 0. So with this one, again, there's no highest common factor. It doesn't jump out as a difference of two squares to everyone straight away. But in fact, this one is. So again, we have a difference. So remember the negative meaning difference. So that's what we want. But our problem here is that our first term, although the y is expressed as a square, the 16 isn't. The 16 isn't being squared there. That's 16 times y squared. So we have to write 16 as a square as well. So we can do that by changing that to 4y all to be squared, with a square outside the bracket, meaning that everything inside the bracket is being squared. And then we think, how do we square, what do we square to get 1? Well, we just square 1 to get 1, because 1 squared is equal to 1. So going back then again, our two brackets, 4y at the front of both of them, 1 at the back of both of them, and a plus and a minus. If you want to do the minus in the first one, the plus in the second bracket, it doesn't matter, it'll still work out. So now again, we have 4y plus 1 is equal to 0, or 4y minus 1 is equal to 0. So I'm going to minus 1 from both sides here, so that I cancel out the 1's, and I'm left with 4y is equal to negative 1. But I don't really like the 4 in front of the y, so I'm also going to divide both sides by 4. And remember, that's staying balanced because I'm doing the exact same thing to both sides of the equal sign. And then I'm left with y is equal to negative 1/4. On this side, it's going to be very, very similar. Add 1 to both sides. 1's cancel. And then I'm left with 4y is equal to 1. Divide both sides by 4. Y is equal to plus or positive 1/4. So y is equal to negative 1/4 or positive 1/4. Excuse me. Now, in the last example for this video, we're going to look at 8x squared minus 50 is equal to 0. So sometimes you kind of have to use both of those methods, highest common factor and difference of two squares. Now, this one, it doesn't really look like your standard highest common factor the way I'm going to do it, but you're really using that same principle of highest common factor. If I look at this, it's a negative sign, okay, but 8 isn't easily expressed as a square and 50 isn't easily expressed as a square. So I think to myself, well, is there a highest common factor there? Well, there is a highest common factor here, and the highest common factor is just 2, okay? But if the highest common factor is just an integer or a real number, okay, so it's not an algebraic term, then if it's an equation, then we're allowed to just divide the whole equation by the highest common factor. Remember I said you can, as long as you divide both sides by the exact same thing, it'll stay balanced. And then I'm left with 4x squared negative 25 is equal to 0 whenever I divide everything by 2. Now it looks a bit more like a straightforward difference of two squares because 4 can be expressed as 2 squared, so that's really 2x squared, and 25 can be expressed as 5 squared. So again, we're going to end up having 2x plus 5 times 2x minus 5 is equal to 0. And I'll quickly solve this like I've done the rest. So if I have those two brackets multiplied by each other to equal to 0, that means that both of the brackets are going to be equal to 0. And quickly solving, I'm going to minus 5 from both sides here. On this side, I'm going to plus 5 from both sides. I'll end up with 2x is equal to negative 5. And on this side, 2x is equal to positive 5. And then I'm going to divide by 2, and divide both of those by 2. Because with difference of two squares, they usually work out similar enough. So negative 5 over 2, or positive 5 over 2. And there's just some quick examples on highest common factor and difference of two squares.